tutorial. In today's tutorial, we're going to be covering how we can develop a classification model to predict classes of data. Now, over the course of the last several tutorials, we've been discussing how we can develop a predictive regressor model in order to predict particular y values given several predictors. But starting in today's tutorial and over the course of the next several tutorials, we're going to be discussing how we can develop a model which is going to take a series of inputs or features and is going to predict a particular y value. So it's going to predict, in this case, a number based on the pixel values that we provide to it. So basically what the MNIST dataset is, it's basically 70,000 handwritten numbers of numbers 0 all the way to 9, right? By high school students and employees from the U.S. Census Bureau. And our goal is to predict from these handwritten numbers what the actual number is. Now we are given what the actual number is in our data set. And so this will be a supervised learning model because we will be giving the labels for each of the inputs that are going in each of the instances. And so what we can do in order to get this data set is go from scikit-learn.datasets. We can import fetch underscore openml. Fetch underscore openml is a function, and we're going to pass in MNIST underscore 784. The reason why we're going to pass 784 is because this data set is going to have 784 features. So 784 inputs. And the reason for that is because when a human writes down a number, we need to know what color each of those pixel values are. And so this is going to be, we're going to basically be getting the pixel value. It's similar to kind of like RGB, except in this case, you're not having three different values for R, G, and B. In this case, you're going to be having only one value. So it's just going to be a value from 0 all the way to 255. 0 being white and going all the way up to black, 255. All right. And so you're going to be getting 784 of those rows, of those columns, and those rows are going to be mapping to individual pixel values. Not pixel values, but colors for those particular pixels. And then version is going to be equal to 1. So why do we say version equals 1? Well, version, this is the oldest data set that we have. Okay, so that's why we say version equals 1. All right, so from there, we're going to extract the keys here. So you see here the keys from this data set, or the column names, in other words, from this pandas data frame. We're going to have data, and data is actually going to be 784 values within that. So data is actually a very big column, if you will. We're then going to have target, and target is just the y value, what the value should be. So that's what we want the model to be able to predict. We're going to have frame, categories, feature underscore names, target underscore names, description as well, details, and URL. Okay, so we'll get into, we'll be touching through several of those as we continue on in today's tutorial, and in several tutorials rather. All right, and then we also have the values. So let me go ahead and print out the values because I think it is important for you to also know what the values are, just so you can see them. So we're going to have 784 predictors going into the model, remember, and those are going to be colors for each of those pixel values for each of those rows. Now, each row is going to represent an instance. So each row is going to have a target value number, okay? And so you see here that we were able to get all the values here in this case. And you see here that we have here starting off from pixel 1, going all the way up to pixel 784. So you see here that we have 70,000 rows and 784 columns. And the reason for that is because we have 70,000 handwritten numbers. So basically each row is going to represent an instance, or it's going to represent a single handwritten number. And each of the columns in this case is going to be representing each of these, column names from our pandas data frame. But in this case, it's going to be the values for the data field. Okay, so for the data field in this case. And so you see that there. And you see for these y values here, for the y values, these are the values that they should be corresponding to. So you see here the outputs 0, 4, 1, 9, so on and so forth. All right, so you see all of those there. All right, let me go ahead and go down a little bit. And what you see here is, you see also, this is also the description as well. So this is the description of the data set. But let me just go ahead and show it to you below some of the other columns, just that way it's more clear to you. Okay, so in scikit-learn, any data set typically has three attributes. We typically have the data attribute that we already looked at. It refers to the column features and rows of individual instances. And so we had that, basically this idea here of this definition, we had that before, right? We had columns of features and we had rows of instances. So that's our data field. We also have a target value. That's the actual value that we want our model to predict, or the Y value. And then we have a, in all caps, DESCR, or a description of the data set. Let me go ahead now and print out each of these here. So we're going to print out the head, first of all, for the first 10, 10 features, right? First 10 features that we have. And when we do that, we can see here that we have pixel values going all the way from 1 all the way up to 784 there. And so I just said head for the first 10 rows. If I were to print out everything, it's going to be 70,000. Let me go ahead and create another cell here in our Jupyter notebook. And let me go ahead and say y.head10. This is going to be the output values that each of these rows should be corresponding to. So each of these features in these rows should be corresponding to. Let me go ahead and print that out. And so you see that right over there, going all the way from 0 to 9 there. So we can also get the description. So we can say here, let me go ahead and just do this, X description like that. All right. Okay, something's wrong here. I think it's saying description is a key error. Okay, so I think I know why. Let me go ahead and, all right, there. MNIST, sorry, yeah. Okay. Okay, so you see the description there. All right, so this is the description basically of the entire data set, and you can read through that if you want. Now, this actually is something good to read, actually, because it does kind of explain the data a little bit. But in general, there's roughly around 70,000 rows, and there's going to be 784 features as well. Okay, so that's what you have there. And then we have our shape attribute. So our shape attribute is going to tell us how many rows and how many columns of data we have. So in this case, we have 70,000 rows of data, 784 features, right, in our data column in our data set, in our MNIST data set. For our Y values, you see that we have 70,000 rows of data, 70,000 rows of data, and you see that there. All right. From there, what we can do now is we can actually experiment with how to convert these pixel values back to actual what the human actually wrote, right? That's one of the things that we want to know. What did the human actually write? What does this data set actually look like? And so in order to do that, we can first of all start off by taking the input. So we can say x.iloc. iloc just gets a particular row from a data frame by the index. And so in this case, we're going to get the 0th index. And so we can print that out, some digit, and we can print that out. And you see here that we have all these pixel values. Now remember, 0 means white, okay? And it goes from white all the way to black. So it's like essentially it's a gradient, if you will, right? From 0 all the way up to 255. And so 255, as the number gets bigger, we approach more darker values. As the number gets smaller, we approach lighter values, if you will. All right. And so from there, we can say some digit image equals some digit dot to underscore numpy dot reshape 2828. And so the reason why we're converting it to a numpy is because in order to call the reshape, we need to have a numpy array. And so some digit is actually a series, meaning that it's basically a column essentially. And so we want to convert it to a numpy array first in order to call the reshape function. And reshape 2828, it's going to convert those 784 pixel values into a 28 by 28 image. So let me go ahead and print that out, and we will get the output here. All right. So you see here that you have all these outputs here. So so for that for row number 1 there, you see all those outputs. Now let me go ahead and display it to you just that way you can see the output here. So we're going to say plt.imshow. This is going to configure and display the array, and we're going to go ahead and say in binary. That's the data. This data here is binary, and then we're going to go ahead and say axis equals off. So we're going to get rid of those y and x axes, and then we can call the plt.show. That is optional when you're in Jupyter Notebook, although when you're in a script file, that will not be optional. So in this case, imshow will already display it to you. Okay, so you see that value there. Let me go ahead and get rid of the some digit image, because that's just going to be a binary numpy. It's just going to be a numpy list. Okay, numpy array. So you see here this value. Now, just taking a look at this, it looks like either an S or a 5. But in this case, since they're all going to be numbers, it's going to be a 5. And so you see that that's a human written 5. Okay, so there you go. Now, the question is, now that we have this output, the question is that over the course of the next several tutorials, how are we going to be creating a model to predict these outputs, to take a look at basically a series of zeros through 255 and see whether or not what number that is going to be, whether it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what number it's going to be. And so this is going to be classification, because we're going to be grouping the data into particular classes. In this case, we're going to have 10 classes of data due to the fact that we're going to have 10 digits in our system of numbers. And so now the question now is, at this point, is how do we get our training set and our test set? Because remember, before we even did our data visualization of our housing data frame, what we first did was we first got a test set and we got a training set. And we even went through stratification and all of that. Now, thankfully, now that we've already done that in the housing data frame, we have experience doing that. The MNIST library actually has already done that for us. The reason for that is because MNIST is typically used for machine learning processes. And so because of that, they've already created a training set and a test set for us in the way they ordered the data. And so in order to get the training set is the first 60,000 instances of the data. So the first 60,000 rows, and the test set rather is the 60,000 and above. So basically 10,000. So since we have 70,000 rows in total, it's going to be 60,000 and above. So that means that for every one test set instance, we will have 6 training set instances. So that means every 1 out of 7 is going to be our test set. That's the ratio, if you will, right? And so we can go ahead and print that out, and that goes to show that roughly 14% of our data is in our test set. And so we can say 1 minus that value, and we can get an output. 86% of our data roughly is going to be in our training set. Now, this is a little bit different than what we did before. Before we had, I believe our ratio rather was 0.2. 0.2 of our overall data set, 20% was going to be our test set, and then 80% was going to be in our training set. Although in this case, it is a little bit different. Okay, but that's a decision that MNIST has made, and it's not a big difference really. All right, now some things to note here about how it has organized this data. Let me go ahead and fix that there. All 10 numbers. All right. So one thing to notice here is that the training data set is randomly ordered. So it is randomly ordered. So it's not going to go simply from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It's not going to do that. Instead, it is going to actually randomly order it. That being said, each of those rows will contain all 10 numbers. And the reason for that is because we don't want duplicated numbers. So that way, our model doesn't have in one row maybe all ones and then all zeros. We want our data to be very much data that in every single row is going to be random. It's not, you can't find hidden correlations in the data. The goal of our model is not to predict, if the rows follow this particular pattern, then the next row will follow that particular pattern. The goal of our model really is just to look at a single instance of the data and see what is the number actually going to be. What's the output value? Not take a look at what order we're ordering these numbers in, because that's really irrelevant in this particular case. All right, so there you go. There is our MNIST data set, and that is basically a brief description. I hope you understand the data set at this point. That was the main goal of today's tutorial. We're going to be going over this data set. We're going to be covering this data set much more in depth as we continue onward. But this was basically a brief overview of, first of all, what classification is, as well as what the MNIST data set provides to us and how we can work with that. And I will see you in the next tutorial.